Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra 2 notes. And today we're looking at section 8.1b. Alright, so this is the second part of 8.1, and we're looking at how do I solve word problems involving exponential growth. Alright, so this is stuff, this first equation is stuff that you actually did in Algebra 1. So hopefully it's a little bit of a get your brain back into it kind of deal here. And the second equation is a little bit new, but hopefully nothing too crazy. All right, so here we go. Exponential growth model, this first one. So we're really looking at two different types. All right, so we're looking at this y equals a, 1 plus r to the t, and then the second one we're looking at is a little bit more complex, but as you notice, it's kind of the same format, except for there's just this one new letter, there's this n in here. All right, we're going to talk about what that n means. All right, so let's start out with the easy one here, exponential growth model. So this is when things are growing exponentially. There's a lot of things in this world that grow exponentially. There's also a lot of things that decay exponentially. But this is how we find out, hey, how much is actually in this account, or how much is that house worth after 5 years or 10 years or whatever it might be. All right, so here we go. A is the initial amount that you're starting with. All right, so that's the initial amount that you're starting with. So initial. All right, so that is my initial amount, and R is the rate. That's pretty self-explanatory. That's the rate, and T is exactly what you thought. It's the time. All right, so remember here, you got to change this rate to a percent to a decimal. All right, a couple other things here. That 1 plus r is what we call the growth rate. So it's going to be like if you grow at a rate of 5%, 5% as a decimal is 0.05. Remember how we move it twice? So now this is going to be 1 plus 0.05, which is going to be 1.05. That is the growth rate. It's growing at 5%. So it's growing. It takes that 100% of what you already had in there, and it tacks on 5% each year. All right. So here we go. Sarah is going to school at UW-Madison next year. The cost of in-state tuition will be $9,000 in the fall. All right. Knowing that the tuition costs have been increasing by 6.5% each year, she wants to know how much that tuition is going to cost 5 years from now during her last year at college. All right, so a couple different things here. I like to circle the numbers, and we're going to label these things. Circle those numbers. So this 9,000 is my A. That's my initial amount. And this 0.065, don't forget to move that, is going to be my R. And then this 5 years is obviously going to be my time. So now it's just as simple as, hey, just plugging these guys in. I get y equals a, 1 plus r to the t. So this is going to be my a is $9,000. And then I have 1 plus 0.065 to the 5 power. All right, and now it's really just plugging this guy in your calculator, and it's making sure you know how to plug this guy in your calculator correctly. All right, so you got to make sure that you put the parentheses in the exact same spots. Even if I'm doing this, I like to just go through and do it step by step because I know how to do the PEMDAS. All right, and you should too. All right, so now in the PEMDAS, it tells me that, hey, I have to add in those parentheses first. So I have 9,000. 1 plus that is going to be 1.065 to the 5th power. All right, now in your calculator, you can just do 1.65 to the 5th power. Then I would just hit equals and then hit times by 9,000, and you should get this figure right here, $12,330.78. All right. Awesome. So that's what you should get. So try that in your calculator a couple different ways. Make sure that you know how to get that so you can repeat that in the next couple problems here in this chapter. All right. So here we go. And the second part of the question is that room and board is $8,000, but it only increases by 5% each year. What will that cost be in 5 years? So again, here we have the A, here we have the R, which is 0.05, and here we have 5, which is the T. All right, so now let's plug those guys in. I get 8,000. 1 plus 0.05 to the t power, which is 5. All right, so now here in your calculator, you can do 8,000, 1.05 to the 5 power. You can put 1.05 to the 5th power. Do that exponent first, then multiply it by 8,000, and you should get 10,000 $210.25. All right. Make sure you label that, guys, dollars. It's a word problem. All right. So make sure you know how to get that. Make sure you get that. That one's not too bad of pretty much just plugging that and chugging that in your calculator. All right. So now we move on to compound interest, which is a little bit different because this compounds more than just like once a year. Okay. This now compounds like quarterly or monthly or different things like that. And that's the only reason why this n is different. Everything else is the same, but now I have this n, which is a little bit different. And I want you to write in here, n equals the number of times it compounds per year. All right, so it's the number of times it compounds for years. So annually would be n equals 1. All right, if I did quarterly, how many times does quarterly happen per year? It's kind of like how many quarters is there in a dollar? Quarterly happens 4 times per year. Monthly is n equals, how many months is there in a year? 12. And daily, that's the biggest one, because how many days is there in a year? N equals 365. All right, so there we go. Just a couple different things there, what your N might look like. Semi-annually would be twice. It happens twice per year semi-annually. So this is really kind of the same deal here. All right. So here we go. It said, what would the value of your, it says that, hey, you inherit $10,000 from your grandparents. Ooh, that's nice of your grandparents. You decide to put that in an account for 30 years. That's good for you. And it's got this interest of 0.05 for an interest. What would the value of that account have if it compounded annually? Okay, so here we go. If I plug these guys in for annually, my N is equal to 1. So this is going to be my 10,000 is my initial amount. 1 plus my R, which is 0.055 divided by 1, raised to the 1 times my T, which is 30 years. All right, so now this one becomes a little bit more tricky in the fact that, hey, what do I have to do first here? Okay, so in your calculator, I would do this first. I would do 0.055 divided by 1. Okay, in this case, it's just going to be 0.055. Okay, then I would add the 1 because that comes in the parentheses. Okay, now you have to raise it to the 1 times 30. So raise it to the 30th power, and then finally multiply by that 10,000, and you should get $49,839 and some odd cents there, but I just rounded it to that. All right, awesome. So make sure you know how to get that. That's a little bit trickier in your calculator. Try it a few times. If you don't get it, I can help you if you need as well. All right, so now quarterly, as we go on here, quarterly is going to be the same, but my N changes to, how many times does quarterly happen per year? 4. What about monthly? How many times does that happen per year? That's 12. And then daily, my N happens 365 times. Okay, so I'm just going to go through and set up these equations as we go through here. I get 10,000. I get 1 plus 0.055 divided by 4 raised to the, and here's where I like to write it, 4 times 30. Okay, so kind of put that in parentheses as everything up top, because you got to make sure when you plug that in your calculator, you don't raise it to the 4th power and then multiply that by 30. You got to make sure you raise it to the 120th power. Okay, so hopefully that makes some sense. Now this guy here, I get 10,000, and then I get 1 plus 0.055 over 12, and then 12 times my 30, and I like to put this whole thing in parentheses. All right, awesome. And my last one is daily 10,000, 1 plus 0.055 over 365 raised to the 365 times 30. Okay. So again here, I'll just kind of go through and just talk through these. So hopefully this makes a little bit more sense. In your calculator, I would do this just step by step. I would go 0.055 divided by 4, hit equals. Go plus 1, hit equals. Now you have to raise it to the, make sure you have parentheses, 4 times 30. All right, so make sure you raise it to the 120th power. And then you multiply by that 10,000, and you should get, and let me make sure I got this right, 51,488 and some odd cents there. I just rounded it to that 88. All right. The next one, now you put that 0.055, you divide by 12, you add the 1, and then you raise it to the 12 times 30. All right, which is going to be a big number. Then you multiply whatever that is times 10,000, and you should get $51,874. All right, and here if it compounds daily, so if you compound daily, make sure you do this divided by 365. Make sure you add the 1, and then you raise it to the 365 times 30. Okay, that's going to be a huge number that you raise it by. Then you got to multiply it by 10 grand, and you should get $52,063. All right, awesome. So again, there are those two different types of equations, the compounded interest. So if you ever say that it's compounded, that compounded is a big word, that's when you use this equation. If it's not compounded annually or semi-annually or biannually or whatever it might be, then it is just the regular equation that we talked about up here, kind of that easier one. All right, awesome. So again, thank you for listening to Mr. Laxton's video on these notes, and have a good rest of your morning, afternoon, or night.